Hello students, welcome to Siri Pathshala. In today's class, let us continue with the problems in exercise 7.2, problems based on coordinate geometry. In this exercise, we are dealing with the problems of section formula. Okay, let us continue with the problem number 6. That is, if 1, 2, 4y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find x and y. Okay, so let us consider the points as A, B, C, D. Okay, the vertices of a parallelogram. Parallelogram andre Samantara Chaturbhuja. Okay, so problem number 6. Let us draw or sketch of a parallelogram. And here, if we consider the vertices as A, B, C and D, the vertices are A, what is that? 1, 2, B, 4y, this is 1, 2, B, 4y, C, that is x, 6 and that is x and 6. Your last point D is 3, 5. Coordinates of D are 3 and 5. Okay, so these are the vertices of a parallelogram. To solve this problem, we need to know the properties of a parallelogram. Yes, what is a parallelogram? A quadrilateral in which both the pairs of opposite sides are parallel as well as equal. So here AB is equal to CD and AD is equal to BC. And one more property, what is that? About the diagonals. Here, which are the diagonals? If I join A and C, I get one of the diagonal AC and BD is another diagonal. Here, diagonals of a parallelogram bisect each other. Yes, what does it mean? The point O divides these diagonals into two equal parts. I mean, AO is equal to CO and which other diagonal? OD, BD is the other diagonal, OD is equal to which one? BD. Okay, they bisect each other. Okay, equal parts divide madutte. Which point? O. So, what do you say now? O is midpoint of AC as well as BD. Okay, eradakku O midpoint. Okay, so now let us use that property to solve the problems. I am erasing this because this is not required now. Okay, so let us write. Let the vertices of a parallelogram be be A 1, 2, B 4 and Y, C x and 6 and D 3, 5. These are the four vertices in order. We know that diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. Bisect each other. So, O is the midpoint of AC and BD. AC and BD. Okay, what is midpoint formula? That is x1 plus x2 by 2 and y1 plus y2 by 2. Okay, now let us consider AC as the diagonal and O is the midpoint. When AC is the diagonal, the coordinates of point O are coordinates of the midpoint O. Midpoint O are How do you write now? Here A and C are vertices. So x1 plus x2 by 2, that is 1 plus x by 2, and y1 plus y2 by 2, 2 plus 6 by 2 are 1 plus x by 2, 1 plus x by 2 and 2 plus 6 by 2. These are the coordinates using midpoint formula. So this is equal to 1 plus x by 2, or we can write it as x plus 1 by 2, and 6 plus 2 how much? 8. 8 by 2 is 4. So these are the coordinates. Now if BD is the diagonal, let us find the same. Now when BD is a diagonal, BD is the diagonal, midpoint O is equal to midpoint O. The coordinates of the midpoint O is which are the coordinates now? B 4y and D 3 5. So x1 plus x2 by 2, that is 4 plus 3 by 2, and y plus 5 by 2, y1 plus y2 by 2. So 4 plus 3 by 2 and y plus 5 by 2. These are the coordinates of the midpoint. So 4 plus 3 is equal to 7 by 2 and y plus 5 by 2. Here O is the common midpoint for both AC and BD, isn't it? It is the midpoint of AC as well as BD. So obviously coordinates must be equal, isn't it? So x coordinate x plus 1 by 2 is equal to 7 by 2, and y coordinate 4 is equal to what? Y plus 5 by 2. Okay. Now let us compare now by comparing the midpoints. What do we get now? X plus 1 by 2 is equal to how much it is? 7 by 2. So cross multiply and find the value of x. So 2 into x plus 1, that 2x plus 2 is equal to 7 2s are 14. So 2x is equal to 14 minus 2 is 12, and x is equal to 2 6 are 12. X value 6. Okay, now let us compare y coordinate. Okay, y coordinate, here it is 4, there it is y plus 5 by 2. Okay, so let us write y plus 5 by 2 is equal to what? Is equal to 4. So y is equal to 4 2s are 8 minus 5. Okay, so y plus 5 is equal to 8. So y is equal to 8 minus 5. So y is equal to what do we get? 3. So we got the values of x and y. X is equal to 6 and y is equal to 3. Okay, these are the required values. So that's it. So very simple problem, and it's very important also. Please practice it. Now let us go with 7th problem in this exercise, that is find the coordinates of a point A where AB is the diameter of a circle whose center is 2 minus 3 and B is 1 4. Okay. Now see, let us draw a rough sketch of this problem. This is problem number 7. Problem number 7. Okay, so let us draw a circle. Okay, yes, here AB is the diameter of the circle. Okay, so AB is the diameter. So this is center O, and end points of the diameter are A and B. Okay, which coordinates are given in the question? Coordinates of a point A. Okay, find the coordinates of the point A. So we need to find the coordinate of A, this point. Okay, and which are the points given in the question? Here center is 2 minus 3. So coordinates of the point O is given 2 minus 3, this point. And another point is given. What is that? It is 1 4. Another end point. The point B is 1 4. Okay, we need to find the coordinates of A. Here O is the center of the circle. So what is that? It is the midpoint of AB, diameter AB. Okay, so let us consider another end point, the points of what coordinates of A as xy now. So and O is the center, that is the midpoint of AB, and B14 is another point. Okay, right now given that center of a circle that is coordinates of the center, okay, coordinates of the center of a circle coordinates of the center of a circle given much it is 2 minus 3. Okay, then one of the end point of the diameter, end point of the diameter are 1, 4. Okay, now let A xy be the another end point. Now A xy be the other end point of the diameter. Okay, so since O is the center, it is the midpoint. Since O is the center of the circle, it is the midpoint. Center of the circle, it is the midpoint of AB. Midpoint of AB. Okay, so let us use midpoint formula. What is midpoint formula? x1 plus x2 by 2, y1 plus y2 by 2. Okay, so let us use midpoint formula now. Midpoint O is given by the coordinates. Yes, 2. That x coordinate is 2 is equal to, yes, A1, we have taken this as xy, isn't it? So x plus 1, x1 plus x2 means x plus 1 by 2, and y coordinate of the center, that is minus 3, is equal to y1 plus y2 by 2, that is y plus 4 by 2. Y plus 4 by 2. Let us simplify this now. So 2 2s are 4. 4 is equal to x plus 1. So x is equal to 4 minus 1, it is 3. Therefore x is equal to 3. And here y plus 4 by 2 is equal to minus 3. So transpose minus 3 into 6. What do we get? It is minus 6 is equal to y plus 4. So y is equal to minus 6 minus 4. So it is, what do we get? Minus 10. Therefore y is equal to minus 10. So which are the coordinates of A? 3 and minus 10. Therefore the coordinates of A are the coordinates of A are 3 minus 10. 3 minus 10. 3 minus 10. This is 7th one. Very simple problem. Now let us go with last problem in this exercise, that is 10th problem. Find the area of a rhombus if its vertices are 3, 0, 4, 5, minus 1, 4 and minus 2, minus 1 taken in order. And here there is a hint. area of a rhombus formula is given, that is equal to half into product of diagonals. If we consider the diagonals as d1 and d2, it is half into d1 into d2. That is the formula to find area of the rhombus. Using this formula, we are going to find the area of the rhombus. But coordinates are given. So what to find? In the beginning, we need to find the lengths of d1 and d2. That is using distance formula. We cannot use section formula here to find the distance. Okay, so let us continue with the problem now. Let the vertices of a rhombus be A 30, B 45, C -1 4 and D -2 -1. Okay, so area of a rhombus formula is area of a rhombus A is equal to 1 by 2 into product of the diagonals means d1 into d2. Okay, so see, let us draw a rough sketch of a rhombus. In rhombus, all four sides are equal, isn't it? So let us draw a rhombus like this, and these are the coordinates A, B, C, D. Okay, so let us draw the diagonal. AC is one of the diagonal. Let us consider it as D1, and BD is another diagonal. Let us consider this as D2. Okay, so let us write the vertices. Which are the vertices? A 30 and B 45, C -1 4 and last vertex, that is D is -2 -1. So let us consider the vertices of A and C and find D1 using distance formula. What is distance formula? It is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us write the formula once. Distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, let us consider AC now. So diagonal AC is equal to square root of x2 minus x1. This is x1, y1, x2, y2. Okay, so -1 -3. Okay, -1 -3 whole square plus y2 minus y1. Here y2 is 4, y1 is 0. So 4 minus 0 whole square. So it is equal to -4 whole square. -4 square is plus 16. 16 plus 4 square is how much? 16 only. Okay, so 16 plus 16 is how much? Square root of 32. This can be written as, 32 can be written as what? 16 2s are, isn't it? So square root of 16 how much? 4. So 4 root 2 units. Okay, this is diagonal 1 or D1. So D1 is equal to length of diagonal AC is equal to 4 root 2 units. Okay, now let us find the length of the diagonal. Which one? BD. Okay, so diagonal BD is equal to yes, what is the length? Using distance formula. Here B x1, y1, x2, y2. So -2 -4 whole square plus y2 minus y1. Okay, so -1 -5 whole square. Okay, so let us find the line. So minus 2 plus minus 4 is minus 6 whole square. It is minus 6 whole square plus here also minus 6 whole square. So minus 6 whole square, 6 square is 36. Minus 6 square is also 36. So 36 plus 36. How much it is? 72. Can we write 72 as 36 2s are? Yes. So we can write this as 36 2s are 72. Square root of 36 is 6. So 6 root 2 units. So length of diagonal BD, that is D2, is 6 root 2 units. Now let us apply the formula. What is formula? A is equal to, area of a rhombus is equal to half into D1 into D2. So what is area? Let us multiply. Therefore A is equal to, that is area, A is equal to 1 by 2 into D1 4 root 2. Okay, 4 root 2 into D2 is 6 root 2. Okay, so here 2 1s are 2 2s are. So 2 6s are, how much? 2 6s are 12. Okay, into root 2 into root 2. What do we get? Root 2 whole square is nothing but 2. So 12 into 2. So 12 2s are 24 square units. Okay, 24 square units. Okay, 24 square units. So area of the rhombus is how much? 24 square units. That's all for today's class. So let us end today's session. By this we can finish with the chapter coordinate geometry. ಪಾಠ ನೋಡ್ತಾ ಇರೋರು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ಅಂತ ದಯವಿಟ್ಟು ಕಮೆಂಟ್ ಮೂಲಕ ತಿಳಿಸಿ. ನಿಮ್ಗೆ ಇಷ್ಟ ಆದರೆ ಖಂಡಿತ ಲೈಕ್ ಕೊಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಶೇರ್ ಮಾಡಿ, ಅದೇ ಥರ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ ಚಾನೆಲ್ನ. ಸೊ ಲೆಟ್ ಅಸ್ ಎಂಡ್ ಟುಡೇ ಸೆಷನ್. ಥ್ಯಾಂಕ್ ಯು ಆ್ಯಂಡ್ ಬೈ.